All right, so here's the Mathematica mod function. So 5 mod 2 is 1. 10 mod 6 should be
4.
All right, so if we want to say like 61 was one of our primes, and we want to see if 60 shows up as a square, what should we do?
So we need to look at the squares mod 61.
Okay.
And maybe stop when we get to a 60.
All right. So how would we write that program?
So we could start with a counter.
Okay.
So like I guess we can just.
Oh, sorry. Jeez. Sorry about that. Trying to reach around. Okay, so maybe I can try to type here. 4. I equals.
I guess we can start at 1 squared.
Okay, I equals 1.
I less than, maybe we can start with 100.
Okay.
I plus plus.
All right.
And then mod. So you can do mod of I squared and 4.
Why 4?
No, I squared and 61.
Okay. All right.
And then we need to say that if because we could get one number where we know the value being squared equals 60 mod 61, because we could say if this
If mod I squared 61
equals 60.
Okay, and then these if tests, you need 2 equals 60. Okay, then what do you want to do if that ends up being true?
Say print I.
Okay.
All right.
And just I think I need a semicolon there. That's what you want to do?
Yeah.
All right.
11 squared, 50 squared, and 72 squared.
Okay, so what is 11 squared?
So 11 squared is 121.
Okay. And what is that mod 61?
That is indeed negative 1, because 61 times 2 is 122.
Okay. And then we tried. We wanted to try 97. So do we think 97 will have a square?
We do. 97 is 1 mod 4.
So will minus 1 be a square? 97. Not 60, but
96.
96.
22 and 75.
Okay, so 22 squared. Am I still on camera?
Yep.
Is 484. And if that's minus 1, that should tell us that 485 is divisible by 97?
So that would probably be 97 times 5,
Yep.
which is 450 plus 35, 485.
Okay. And what's one that we think will not have a square?
So, like 102.
Well, why?
103.
All right, 103 is a prime. Well,
It's 3 mod 4.
we can check. Mathematica has a prime checking function called prime q. Do you think 103 is prime?
I think it is.
True. Okay. So now let's check. We really have to check up to 103, but I'll just do 200. If I squared mod 103 is 102, stop. And if not, then we didn't find any. So there's,
What we thought.
so your conjecture seems to be working, at least with numbers we check.
Yep.
A little bit more difficult to prove this. But we just learned something today, that if a square is if a prime is
1 mod 3, then you'll see.
if a prime is 1 mod 3, mod 4, then -1 is a square.
Yeah.
And if a prime in that mod, if a prime is 3 mod 4, then -1 is not a square. And that is a property that numbers have.
Cool.
It's a cool property. And this is an introduction to a topic in number theory called quadratic reciprocity that was studied by a lot of mathematicians and sort of finally understood and proved by Gauss. Like lots of things. All right, good work, guys.